All right, so we are on to lesson 4 of chapter 12 in our combined 11 and 12 unit. So what we're going to talk about today is how many solutions an equation has. So that is your goal, to be able to identify the different number of or different types of solutions. So we have 3 options. The 3 different types of solutions are laid out for you on this page. We can have the kind that we're most familiar with. So far, we've been solving equations that all have one solution. So that's a linear equation that only has one variable, like this one here. We have a y, and that's our only variable. And if only one value for this y makes the equation true, then we say it has one solution. So we're just going to transform this original equation into an equivalent equation using those inverse operations we've been talking about until the variable is alone on one side and a number is alone on the other. So in this case, if I want y by itself, then first I need to start by getting rid of 57 and 9/10, and then I can get rid of this 98 and 2/10. So I'll first start by subtracting 57 and 9/10 from both sides. So on the left side of the equation, 57 and 9/10 cancels because those are inverse, additive inverse. So all I'm left with is this negative 98 and 2/10 y. And on the right side of the equation, when I subtract, I get 245 and 5/10. So now to isolate y, I'm going to divide by negative 98 and 2/10. Whatever I do to one side, I have to do to the other. So those will cancel so that all I'm left with is y. And on the right-hand side, I need to divide that out. And I end up with negative 2 and 5/10. So as I simplify this equation, I can solve and get the variable on one side and a number on the other. That's my one solution. This is the only number that makes this equation true. But sometimes we will find equations that have infinitely many solutions. And this is the case if we have a variable or we have an equation in one variable, but there are an infinite number of solutions that could balance this equation and make it true. So we're always looking for a true statement, and I'll show you what I mean by that. So in this equation, 9 plus 4p minus 2 equals p plus 3p plus 7. First, I'm going to simplify and combine like terms. So over here, I have a 9 minus 2, which is 7. So I'm going to simplify that to 7 plus 4p. On the right side of my equation, I can combine p plus 3p. So I'm going to simplify that to 4p. Well, now I'm going to try to isolate the p. So I'm going to go ahead and subtract 7 from both sides. All I'm left with on this side is 4p, and all I'm left with on this side is 4p. So if I want to truly isolate my variable, I can divide by 4 on each side, and then I end up with p equals p. This is a true statement, and this is always the kind of statement you're going to get when you have infinitely many solutions. So some other examples could be if you simplified the equation and got 7 equals 7, or 10 equals 10, or r equals r. Anytime you get a true statement like one of these, it means you have infinitely many solutions. And our last scenario then is when you have no solution. So this means there's no number that I can substitute for g that will ever balance this equation and make a true statement. So let's go ahead and solve this, and I'll show you what that looks like. So first I'm going to use the distributive property to simplify the left side. So this becomes 6g plus 12. And on the right side, I don't have anything to simplify. So now I can use my inverse operations. I'm going to start by subtracting 12 from both sides. And then I'm left with 6g equals 6g minus 3. And now I'll subtract 6g from both sides. So over here I get 0, and over here I get negative 3. Well, this looks similar to infinitely many, except that this is not true. 0 does not equal 3. So in this case, we would say no solution.